On this course, I'm going to be guiding you through the basics of synthesis to give you an understanding of the process and help you gain more confidence in using synthesizers to create the sounds you want. One main aim is to prevent you from feeling daunted by the overwhelming nature of some synthesizers, so you can see just how much can be done with relatively little, but also the huge amount you can achieve once a broader technical knowledge has been acquired. Unlike sampling, which is the process of taking existing sounds or samples into the domain of MIDI and replaying them, synthesizing is creating sounds from scratch out of waveforms. Although there are some crossovers with sampling and synthesizing, for instance with wavetable synthesizing, as we'll see later on, the basic controls and sections on a synth of any type are almost always the same. Every synthesizer starts with sound generators, which produce waveforms of some kind. On the majority of synths, there are at least two of these, typically called oscillators. And the kind of waveform the oscillator produces determines the kind of sound you get. From a clean and pure sound with not many frequencies, made by a sine wave, to a richer or noisier one with a lot more frequencies, made by a sawtooth wave. A synthesizer allows you to blend together different sounds or waveforms to produce a more complex sound, consisting of different layers or textures that you can control. The signal then normally goes into a filter of some kind, which can be used to remove or filter out different frequencies. And this can be done to the combined oscillator output, or individual oscillators, or sometimes both, depending on the complexity of the synth. Then, at the end of the synth, there is typically an amplifier envelope of some kind, which is simply a set of controls that tells a sound how to behave when a note is played. So, whether to carry on whilst the note is held down and stop when you let go, or fade out quickly when you play a note, or fade out gradually after you let go. So this amplitude envelope is perhaps the simplest form of what's called modulation, which is the modulating or the shifting up and down of a particular parameter over time, in this case the synth output level. Modulation using ADSR envelopes like this, or low frequency oscillators, is really common on a synth and can generally be done to all sorts of synth parameters like filter cutoffs, oscillator levels, and so on, to add movement and so interest to a sound. Many synths also have built-in effects, which often include distortion, reverb, chorus, and delay, allowing you to create sounds with improved character and depth on the instrument itself, without the need of additional devices afterwards. When producing, however, it's very common to turn all of the soft synth's effects off to apply your own effects in the DAW for maximum control. The other main type synthesis, like FM or frequency modulation, still have the same basic structure, with oscillators going into filters going into amplifiers. But instead of the oscillators just producing waveforms on their own, they can also be used to modulate one another to produce really interesting and distinctive sounding waveforms. Before we get onto any of that though, we're going to go right back to the start and then work through everything at a nice gradual pace. So don't worry if everything was getting a bit much there. Hopefully now though, you've got more of an idea of the basic structure and sections of a synth.